Good late morning, everyone. So I'm very excited to be here today at Hub Conference. I'm very excited to talk about 3D printing together with our partner Siemens. Why am I excited about it? Because I believe we're actually at a tipping point of the industry. You know, 3D printing has been around for a while, been talked about for a while, but I will share with you today why it is changing and why we are at a tipping point with 3D printing and where the opportunity lies. If you look at 3D printing, where the opportunity is, it's really ultimately, it is about disrupting if we get actually the clicker going. Okay, here we go. It's about disrupting the $12 trillion manufacturing industry. Today, 3D printing is largely focused on prototyping, tooling, a little bit of small run manufacturing. But the real opportunity is about disrupting the $12 trillion manufacturing industry. As we go there, if you look at the market today, the nice thing, it is actually a growing market. So it is growing at 30%, not too bad, especially not too bad for us at HP, given the markets we're in. If we now look at the 3D printing market, the biggest one is actually the plastic market. So plastic is actually where the big opportunity is. And then the second big opportunity is on the metal space. We just have to see here. If we can actually advance the clicker, the slides. There we go. So you see again, 57% is plastics, and we address about 75% of that. But as I said, the large, big opportunity is the $12 trillion manufacturing industry. And that's what we are ultimately going after. $12 trillion, just to give you a rough sense, is about 20% of the world GDP. That's what we see as the opportunity, and that's why we're going after it. Now let me tell you why we think we are very well suited to go after this. If you look at what it takes to be successful, and what HP brings to the table with MultiJet fusion, it's a very new technology. So MultiJet fusion doesn't exist today. It builds on our over 30 years of printing expertise. What does that mean? That means about 5,000 patents that we have, more than 400 patents just focused on 3D printing. It's about material science. For those of you who deal with 3D printing, look at 3D printing, know that it's ultimately about material science. That's what 3D printing is about, and we have lots of expertise in that from printing in general. Now specifically, if you look at our product that we're bringing out, what does it actually mean? How does it come to the table? It's, you break it down into the key components, it's a lot faster. And I'll go into the technology in a moment. I will show you a little video that explains it. But it's essentially up to 10 times faster. You can print at half the cost. You can print at scalability. Scalability means you can print large parts. It's not just little jewelry parts. We believe that ultimately we have the technology today to print parts that are up to 110 inches. For those of you in the metric system, it's about 2.80 meters. That already is there from a technology perspective, and from a 2D printing that we're leveraging and using to get to 3D printing. And last but not least, it's about voxel level printing. And I'll get to what voxel level is about. So wait till a few more minutes and I'll show you voxel level printing. Now, let me also show with you a little video that essentially explains the technology.
HP's MultiJet fusion technology produces high-quality, functional parts at a production speed which is 10 times faster than today's competing products. Unlike the slow point processes of some current technologies, HP's MultiJet fusion technology processes parts in 2 fast area-wide passes to achieve top-speed part production. The process begins by applying a layer of material in a work area. Then, in one continuous pass, we print liquid agents across the full working area using HP thermal inkjet arrays. In the opposite direction, we combine the layering and energy fusing into one continuous pass. This HP proprietary architecture, using HP's thermal inkjet arrays, is capable of printing 30 million drops per second along every single inch of bed width. To achieve part quality at speed, HP invented a multi-agent printing process. In this process, a fusing agent is applied on a material layer where the particles are meant to fuse together. A detailing agent is applied to modify fusing and create fine detail and smooth surfaces. The area is exposed to energy, and reactions between the agents and the material cause the material to selectively fuse together to form the part. The process is then repeated until a complete, high-quality, highly functional part has been formed. This is how HP's proprietary area-wide processing compares with today's popular point processing technologies for building functional parts. In the time it takes these slower point processes to build 1,000 parts, HP's MultiJet fusion technology would have created several thousands of parts. Using HP's proprietary multi-agent printing, the HP MultiJet fusion technology achieves new levels of part quality at these breakthrough speeds.
So you're probably wondering, why is that important? And let me go a little bit through the economics here. I said earlier, we believe the opportunity is to get into the manufacturing space. If you're in manufacturing, it's about cost per part, and it's about speed. So ultimately, you will always make the trade-off. Do I use analog manufacturing, injection molding, or some other way of manufacturing, or do I use 3D printing? And it's very simple. You essentially compare the cost per part. You look at what's my cost per part using 3D printing, what is my cost per part using injection molding or some other traditional manufacturing process. The benefit that analog manufacturing has, the more you produce, usually the less the part costs. The advantage that 3D printing has is the cost per part stays the same, and you can customize, you can look at it differently. So today, where we are, and we picked an example is here's a gear part. For this particular one, with today's MultiJet fusion technology, you can produce about 55,000 parts. That's the break-even point. And what we looked at, we developed actually a fairly detailed model around what's driving the cost. What you see is there are a few large drivers. The biggest one in plastics is actually materials. So we started to think, what is the opportunity? How do we drive materials costs down? And developed what's revolutionary for the industry, an open materials platform. And I will show you in a moment how the materials platform works, how you can make that actually successful, and why it's so revolutionary. Looking again at the economics, let's just assume for a moment, you drive materials costs down, you improve productivity by 4x, let's say, which, by the way, for us is not a big deal. 4x productivity, having been in the business for 30 plus years, it's about experience curve, it's about the learning curve, it's about getting improved productivity. And materials cost down, you could envision at that level a million parts. So just imagine it, you move just the break-even point from 55,000 parts to 1 million parts. Now all of a sudden, it becomes a lot more interesting for manufacturing to use 3D printing. And that's why we are so bullish on our technology. That's why I'm so bullish on where the 3D printing industry will go. So then we start, okay, we actually need to have a printer, our own printer. And we started to manufacture it, and we went to our supply chain operations, manufacturing operations, and said, please manufacture that for us. They started looking at it and said, like, you know what? There are quite a few parts, actually. Today, it's less expensive to do 3D printing. So if you look at here, the black parts in this particular 3D printer, that's actually our 3D printer, they are manufactured today with a 3D printer. So effectively, the printer prints itself. Now we had to manufacture one of them, so we could start the printing for the other ones. If you now get the scale of economics and breakthrough economics that I just talked about earlier, you could see very easily that up to 90% of the custom parts will be 3D printed. And that's not driven by a kind of marketing gimmick. It is actually driven by our supply chain organization, by our partners. So we actually don't manufacture the printer entirely itself. We have contract manufacturers who do it for us, and they're using essentially the 3D printer. So just think about it, what the potential ultimately is to expand the market. As I said, today it's about 18 billion. We think we can easily double it in the next 5 years if a few things come into place. One is the materials cost and selection, driving it down. I talked earlier about it makes up more than 50% in a printed part. If we get material selection expanded and down, if we improve product capability, not too much doubt about that we can do that because we've done it before in other parts and other technologies. And third, designing for additive. So enabling the tools, having the tools in place that you can actually design for 3D printing. Today, you cannot really do it yourself, ultimately. So what we said is, as we look at it, we need to develop partnerships. And I'll explain a few of the partnership ecosystem. The first one is around materials. So we developed an open materials platform. So unlike other 3D printing companies, we do not develop our own material. We do not sell our own material. We have no interest in that. We developed an open platform. We announced 4 partners today. There are others that are in the works, but the 4 big ones we have are BASF, Arkema, Lehman Foss, and Evonik. What they do, we give them an opportunity to innovate around materials and to drive materials forward. Because we cannot do it as an OEM. It's impossible to do all of that. The second area is around verticals. You need much deeper vertical expertise. So what we've done over the last couple of years, we worked very closely with experts, innovative companies in key verticals. BMW, automotive, Johnson & Johnson, medical, Jabil, particularly excited about Jabil, manufacturing, contract manufacturing. Jabil, who operates on very thin margins, is looking at how to use 3D printing, how to use MultiJet fusion to improve its own margin, to improve its own manufacturing. And Nike, the consumer goods company, and obviously working closely with them. And then the third area we need to develop and drive forward is around standards and design software. So we developed and built a consortium, the 3MF consortium, that we founded with key players, including Microsoft, Autodesk, Siemens are in there, and key design software players. And so what I will do is I introduce now our partner from Siemens, Ulli Klenk, who's here today, who will talk a little bit about how you make design work, how actually 3D printing already works.
Thank you very much, Philipp. My name is Ulli Klenk. And I'm very happy to be here to give you a short, very brief overview in a complete, tiny little nutshell on what we're doing at Siemens to really industrialize 3D printing. And the first thing I want to state actually is this is not about printing Smurfs. We have high-end, really rugged, heavy industry examples in our portfolio today that we have realized. And this is the second thing. This is not about talking about the future, this is today. This is a journey that has started a couple of years ago and is truly picking up on speed. So enough said, let me just give you 3 examples from the Siemens AG, which are business cases today throughout the entire value chain. The first one actually is a turbine vane. Turbine vanes in a gas turbine where we could reduce the R&D times from 5 years to 1. So we dramatically reduced our R&D cycle by 80%. And that quite monetizes is not too hard to guess. The second one is actually what we do in production and also in service is a burner chip within a gas turbine. And this definitely is not a Smurf. This turbine, this burner tip actually has to go into hazardous areas up to 1,000 degrees. And for those of you that come from a material expertise, and I know you're a lot of IT guys, it's Inconel It's a nickel-based super alloy. And now on the test rig, we can actually go up to 3,000 degrees by using this material and optimizing the topologies. So, and the last one actually is a armrest in a tram. And there's a nice little anecdote to it. But the main thing actually, it's always also a service part. So it's spare parts on demand, where we can really personalize the armrest. Sounds silly, is traumatic for the tram driver. Tremendous for the tram driver. So having that said is, we're using all kinds of materials. We're using metals. We're using very, very high-end metals. We're using it in production, in R&D, and also at the end of the life cycle in spare parts, in service cases. And we're using it for metal, and we're using it for plastics. And all these parts actually have to be certified. So I'll come to that in a sec. So, hello. OK. So one thing is we want to enhance our parts. The second thing is we want to enhance our business cases throughout the entire value chain. And the third one is we want to do this globally. And we want to completely decentralize our production sites again. So we want to produce directly, on demand, locally. And this tremendously reduces the CO2 footprint of our processes and our parts. So we can then really, how do I say? Well, spare parts on demand is the buzzword. We can produce on-site, simply shipping the data to the production, to the printer, and then have the parts at the customer on the next day. That's what we're working on. Security is the first topic that comes to mind. There's a solution for that. We learned a lot from the streaming industry, that we can really ensure the production of a highly IP part on site for precisely the amount of times that we granted. So having that all said, what is the backbone to do this? How can we really take these Smurfs into given vertical standards? And it's all based on our digital enterprise software suite that really brings together, on one hand, the PLM environment, so the CAE, CAD, CAM. On the other hand, the factory integration, factory automation, the SCADA and the MES world, which we call MOM, Manufacturing Operation Management, and down to the shop floor, where we really have a closed loop control on the automation of the machines. So having that all said, it's all based on one platform, on one collaboration platform, which we call Teamcenter. So I guess a lot of you, and this is to be very open and very honest, a lot of people are really boring me about this tremendous future of 3D printing, and it's going to be disruptive, and it's all going to happen, and whatnot. Let's come to detail. So what we're doing is we're taking precisely the standards that are given in the driving or pulling, demanding verticals such as automotive, aerospace, healthcare industry, energy sector, where we have the highest preciseness in our PLM environment, starting off with a CAD, through a topology optimization and a simulation in a CAE, and then also the building strategy, for example, in our CAM. And we're taking this to the 3D printing world. I don't know how many of you are familiar with 3D printing and the formats that are given in 3D printing, but let me put it this way. There are highly intellectual brains that are coming up with fantastic ideas and topologies, such as for those burner chips, that really optimize the use of a gas turbine. And then it's broken down to triangles. And triangles are, saying it very frank, and not the precisest way to describe an object. And the worst thing is that these triangles are actually sliced into layers, so you have holes. And there's software that actually repairs these holes and finds these holes. Our idea is very simple. Let's avoid the mistake and go with the G code and the given standards from machine tool systems. The second one is, when we look at the machines today, then they're very open loop. The data is sent to the machines start producing, and at the end of the production cycle, you kind of find if the part was of high quality or not. And that's why we're joining up with HP, because they have a very good approach on a closed-loop control for the machines, which also already meets those standards that are given, for instance, in the pharma industry and also in the healthcare sector. And the next one is we believe in open machines. We do not believe in black boxes where you send something and you don't really know what's going on, and at the end of the process you get a protocol that says the building process was okay. No, we want to have precisely the graphs and how the production went. And this is a perfect match to the open concept that HP is bringing to the market. The last one is, when you look at 3D printing today, that's actually one too far. When you look at 3D printing today, okay, whatever. Can we go 2 on? Okay. When you look at 3D printing today, a lot of the machines actually are built for a laboratory environment. So the material is brought to the machine by hand, the machine is started by hand, the part is taken off the machine by hand and brought to the post-processing by hand. This is not the given standard that we see in production machines. So what we're doing with our partners is we're bringing precisely these standards that have grown over the years and that have highly evolved to 3D printing, and really enabling 3D printing to step into these production lines and 24/7, 365, fully automated production sites. And the last one is actually, and this is also very essential for quality management, is to simply gather the data from the post-processes, such as material blending, where you can really gain a lot of IP, through the building process itself, and the post-processing, such as heat treatment and so on. And these data are all quality relevant. So we bring them together again in this platform we call the manufacturing operation management, which is a unified architecture for the MES and the SCADA environment. So having that all said, I think I could clearly point out that if we really want to industrialize additive manufacturing, it is absolutely essential to have a holistic approach. I know everybody talks about a holistic approach. What does it actually mean? We need to have the material expertise. We in our corporate technology at Siemens, for example, are working on additive since 1989. We've built a gigantic IP on materials and process know-how. We really have to go into the PLM environment, especially the CAE, since the material itself is actually produced on the machine. So all variables that go into the machine, such as laser performance, granularity, speed, heat treatment, or preheatment of the building bed, affects the material. And actually, you can bring features into the material during the production. Automation itself, standardized platforms that fully meet the requirements of the driving verticals and truly allow industrial production. And at the end, the application know-how that really enables us or stimulates our PLM and our material environment. Okay, thank you very much. That's it from my side. Yep. And now it's the two of us together.
Yep. So now, where do we see the future going for 3D printing? The future is about voxels. You're wondering, what are voxels? Remember pixels? Pixels is in the 2D area, voxels is about 3D. And why are we excited about voxel level printing? Because you can define properties at the voxel level. One voxel is 21 millimeter. What does it mean? For a cubic centimeter, you have over 22 million voxels. And imagine what you can do if you can define the color, you can define electric conductivity, you can define texture, you can define optical properties, mechanical properties. So essentially, at the end of the day, your imagination and your creativity is the limit of what you can do with 3D printing. Imagine, for example, you have a health practitioner, a doctor, you have an artificial knee, and it's 3D printed. You can test how it's progressing, how performance is moving forward, how the healing is moving forward. You can have wearable racks, many different opportunities. So again, your imagination, your creativity is the limit. With that, though, thank you very much. I think we maybe have for 1 or 2 questions.
Yeah.
Good.
Let's first get a round of applause for that very detailed presentation. So we've got some microphones set up. If you have a question, you can just make your way to the microphone. You can also raise your hand. If you're nervous about asking a question in English, you can ask it in German, and one of us will try and translate it for you.
We actually do understand German.
These guys understand
we're
German,
actually
so
fluent in German.
Yeah.
please don't be shy.
Yeah.
Yep.
Was there a hand raised? There we go. Yeah, stand right up.
There's one actually back there.
Be bold.
He was
Oh,
first.
I'm sorry. Yes, you first.
Yep, he's first.
The light is blinding me. Man in the red tie, you right there. Go first.
Does it work? Okay. Thank you. Andreas Gördeler, Ministry for Economic Affairs. I would like to know to what extent 3D printing, as you have shown us, is already taken from the economic point of view. To what extent 3D printing in economic terms is it worthwhile already? That is what I don't know. To what extent is it? Maybe in the future, if you look at the production process, 80% less. You have to look at the costs, and not each process can be done by 3D printing. To what extent? What is your opinion?
Yep. So let me maybe answer, and then I'll have Ulli add to it. If you look at it today, it comes back to the economics that you're looking at. That's really how you assess it. Today, for our very own printer, it's worthwhile doing 3D printing. We do 3D printing for our printer. We use it in production processes, in some prototyping. The examples that Ulli talked about were also...
Keep going.
Come over there.
Sorry, we've got our elves building stuff. Excuse me.
Good. So, I mean, the examples that Ulli gave, I think, are very much about economics, right? It wasn't just because it's cute to do it, because it's interesting. It's about economics.
Let me be very clear on this. All the examples I showed, we do because they pay off. And there's two approaches on it. One is actually that we simply can optimize our warehouse costs, for example. We don't have to put the stuff on stock. We produce it when needed. And the second one is actually, especially when we come to the burner tips, we can realize topologies that simply cannot produce in classical production methods today. So if we really want to go into it, I would be happy to have a cup of coffee with you. But we simply can optimize through the cooling channels and also the gas stream channels, the mixture of the gas and the oxygen. So we can go higher temperatures on the gas turbine and also enhancing the lifetime of the burner tip itself. Which increases the temperature delta, so the turbine is more efficient. And this is a business case that is realized today, and there's simply no other way of doing it.
So real examples.
Yeah, it's all done because it pays off. It's true, and this is not the first time that I'm actually confronted with this this point. Oh yeah, sorry.
Yeah, sorry, we have one more question here.
Hello. Hi. Okay. Nicholas Bubner from EY, Ernst & Young. Thank you for the interesting talk. Maybe it's not your task, but do you have maybe nevertheless an idea how that impacts other industries like the logistics industry, the manufacturing industry, and how quickly the impact will apply?
So we believe it will absolutely impact other industries. The manufacturing, the logistics industry. Think about manufacturing today is happening, a lot of it is happening in China. Opportunities to bring it back, to localize it more. Democratizing manufacturing, that's what we see as the opportunity. Logistics, absolutely, it will impact that. And I think it will also impact other machinery manufacturing industry, like CNC machines. It will impact it, what you will do and what you won't do. Absolutely.
You want to add anything, Ulli?
Yeah, I mean, it will clearly disrupt the logistics industry, and we also see that a lot of players in the logistics sector are looking into it. But on the other hand, it will open completely new business models for them as well.
Yep.
Philipp Jung and Ulli Klenk, thank you very much for your presentation. It was a pleasure having you on the red stage.
Thank you very much.